Hi everyone, Assalamualaikum. In this video, we will continue with example 7b for mixing problem under applications of first order ODE for rate in equals to rate out. A tank initially contains 10 liters of pure water. Brine containing 5 grams of salt per liter is allowed to enter the tank at a rate of 2 liters per minute, and the mixed solution is drained from the tank at the same rate. Number 1, how much salt is in the tank at any time t? Number 2, how much salt is in the tank after 15 minutes? Right, to solve this problem, first step, we extract the given information and write into the symbol below, right? We extract this information, okay? Now we check one by one, okay? A tank initially contains 10 liters of pure water. So 10 liters here means for V0, okay? And then brine containing 5 grams of salt per liter is for B, right? And then 2 liters per min here. And the word here is enter, okay? This is rate, okay? And then enter means rate in, okay? R1 equals to 2 liters per min, okay? And then same rate, okay? Means that R2 also equals to 2 liters per min, okay? This is example for rate in equals to rate out, right? And then how much salt is in the tank at any time t, okay? Means we want to find Q in terms of t, okay? And then how much salt? So Q equals to question mark. After 15 minutes, t equals to 15 minutes, okay? So we extract all the information given, okay? Alright, from here, we can see that there is no value for Q when t equals to 0. Means Q is not given. Q means the amount of salt, okay? So if Q or the amount of salt when T0 is not given, so we assume when T0, Q equals to 0, okay? This information is to find C after we integrate, okay? Alright, after that, we substitute V0, B, R1, and R2 into this formula. dQ over dt plus R2 over V0 plus R1 minus R2 times TQ equals to BR1, right? So using linear equation, we continue with step 2, okay? Substitute V0, B, R1 and R2 into this formula, right? So after we substitute, okay, we substitute V0, B, R1, and then R1 here, R2 here, and R2 here. So after we substitute, we get this, okay? dQ over dt plus R2 equals to 2 over V0. V0 equals to 10 plus R1 minus R2. R1 equals to R2. Okay, so means 2 minus 2. And then times T and then times Q equals to B. B equals to 5. R1 equals to 2. Okay, we substitute V0, B, R1 and R2. Alright. Right after that, we can simplify 2 minus 2 equals to 0. So we get dQ over dt plus 2 over 10, Okay. 2 plus 2 is 0, and then 0 times t equals to 0. So we only have 10 in denominator. Okay, and then times q equals to 10. Okay. Then we can write dq over dt plus 2 over 10 equals to 0.2, and then q equals to 10. Right? From the previous slide, we get this. dq over d time plus 0.2q equals to 10. This is similar for standard form of linear equation under first order ODE. Okay, but now we use variable q, okay, and variable time. Okay, variable q is similar to variable y, okay, and variable t is similar to variable x, okay, and 0.2 here means px, and 10 here means qx. Alright. Under linear equation, we need to find if, which is integrating factor, and it is equals to e to the power of integration of px dx. So we can continue with step 3. Okay, find the integrating factor if. Okay, if equals to e to the power of integration of 0.2 dt. Okay, why we get this? Because px now equals to 0.2. Okay, and dx means dt. Okay, right after that, we integrate 0.2 with respect to t. Okay, so we get e, and then we integrate 0.2 here, we get 0.2t when we integrate with respect to t, right? Right after that, we continue with step 4. Find q in terms of t and c. Q means the amount of salt. Okay. Alright, so we compare with solution for linear equation. Okay, y times if equals to integration of qx times if dx. Okay, so in this case, our variable y, our qx equals to 10. Okay, and then dx means dt. Okay, and variable y means q. Okay. Alright, after that, we have q times if, we replace by e to the power of 0.2t equals to integration of 10, and then we replace if by e to the power of 0.2t, and then dt, right? Right, then we can move out constant 10 from integration sign. Okay? And then to integrate e to the power of 0.2t dt, we can refer this formula. If we integrate e to the power of ax dx, the answer equals to 1 over a means constant, and then e ax plus c. Okay? Now we integrate e to the power of constant t with respect to t. Okay? Now our a equals to 0.2 and our x equals to t. Okay? So we still have q e to the power of 0.2t on the left hand side, and then equals to, we have 10 here in front, and then when we integrate e to the power of 0.t dt using this formula, we get 1 over a equals to 0.2, and then e to the power of 0.2t, and then plus c, right? Then we have q e to the power of 0.2t equals to, we simplify 10 over 0.2, so we get 50. And then e to the power of 0.2t plus c, right? Alright, now we want to find q in terms of t and c. Means we need to write q as a subject. So we divide each term from both sides by e to the power of 0.2t. So after we divide each term by e to the power of 0.2t, so we get this. Okay, we have q after we simplify this equals to 50 after we simplify this, and then plus c, we move up e to the power of 0.2t using the properties of indices. So we get times e to the power of negative 0.2t. Right? Now we have q in terms of t and c. Okay? Then we can name as equation 1. Right? From the previous slide, we get q in terms of t and c, where q equals to 50 plus c e to the power of negative 0.2t, and we name as equation 1. Right? After that, we continue with step 5. Substitute t equals to 0, q equals to 0 gram into equation 1 to find c. Where we get this information? Okay? From the previous slide. Okay? We get T0 and then Q equals to 0 gram. Okay, so from equation 1 here, after we substitute this information to find C, so we replace T equals to 0 and we replace Q equals to 0, right? After that, we move 50 to left hand side, so we get negative 50 equals to C e to the power of 0. Okay, e to the power of 0 equals to 1. So we get C equals to negative 50. Right? After that, we substitute the value of C into equation 1 here. Right? Right, the amount of salt at any time t equals to Q equals to 50 minus 50 e to the power of negative 0.2t. Okay, we substitute c equals to negative 50 into equation 1, into c here. So we get this, right? 50 minus 50 and then e to the power of negative 0.2t. Right? After that, we name as equation 2. Okay? Equation 1 and equation 2 actually are the same equation. But equation 1, before we find the value of c. And equation 2, after we substitute the value of c. Right? Right. This is question number 1. Okay, the amount of salt at any time t. Right? And then question number 2, how much salt is in the tank after 15 minutes? Okay, so the amount of salt after 15 minutes, we need to substitute t equals to 15 minutes into equation 2. Okay, so this information we substitute into equation 2. Okay, to find the amount of salt after 15 minutes. Alright, so from equation 2 here, we replace t equals to 15 minutes. Okay, then using calculator, so we get q equals to 47.51. Okay, then we need to put unit for Q here. Okay. And the unit given is gram. Okay. Q means the amount of salt. Okay. So this is the answer for question number 2. Alright. Coming up next, mixing problem for rate in not equals to rate out, which is applications for linear differential equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.